Welcome back, guys. So today we'll be starting numerical integration. So today we'll be learning about the trapezoidal rule. So a method for approximating a definite integral. So something like integrating from a to b f of x dx. So this we can do by using linear approximations on the function f. So the trapezoidal method is something like this. Suppose we have a function f of x. So the way this works, so we'll be just like drawing trapeziums, something like this. So suppose this is x0, this is x1, this is x2 and dot xn, and all these intervals are h. So these are like divided into such trapezias. So this is how it works. So there's a formula is like integrating from a to b f of x dx. We can write it as h by 2 y0 plus yn plus 2 times y1 plus y2 plus up to yn minus 1. So this is the formula. So I will just explain everything. So you can just divide it into steps for solving a problem by trapezoidal rule. So step 1, so take n, that is number of intervals. So this will be given in the question. Now step 2, so calculate h. So h is equals to b minus a by n, where a is the lower limit, b is the upper limit of integration, or the the range. Now step 3, find x0, that is a for first one, x1 that is a plus h, x2 that is a plus twice of h, and so on up to xn, that is b, or that is also equals to a plus n times h. Now step 4, you need to like find the values. So using y, that is y equals to f of x, you need to find out the values of y0, y1, y2 and up to yn. Now finally you will use this formula. So sometimes it is also written as like this is the final step. So step 5, you can write t of n, sometimes it is also denoted by t of n, h by 2 times multiplied by y0 plus y. So it is also written something like sometimes like this, y1 plus y2 up to yn minus 1 plus y of n, so just to make in like complete series. So you can also write like this also, or you can write like this also, because these two are not multiplied by 2, these all are multiplied by 2. So these were the steps. Now I'll just show you in a small example. So let us take this small example. Suppose we need to evaluate this integration and the number of intervals is 6. So we'll start from like step 1. So step 1, n equals to 6. So we did it. So now step 2, we need to find h, the number of like intervals. So upper limit minus 1 by number of intervals. So this is the number of, this is h is called number of sub intervals. So this is what, 0.5 or half. So now you need to find the values of x and y. I'm combining like the step 3 and step 4 in one by making it in form of a table. So that is systematic and that looks good also. So first is 1, and because x0 is 1, so I'm showing it here. So x0 is a is our 1. So the value of y, so putting y here, so 1 square plus 2 into 1, that is 3. Now what is our a is 1 plus 0.5, that is 1.5. Putting the values here, so I'm just use a calculator, something like that. So calculate all the values. So I've just found out all the values. So now I'll just put in the integration. So what, a to b f of x dx, that is, or what I'll again write it as x square plus 2x times dx. So I'll just write it here, that is 0.5 h by 2 multiplied by y0 plus yn, yn is 24, and all the terms that are multiplied by 2, 2 into y1, 5.25 plus 8 plus 11.25 plus 15 plus 19.25. Use a calculator and just find out the value. Finally it will turn out to be 36.125. So this is the integration, numerical integration by trapezoidal rule. So thanks for watching it.